Hey Eric, here at Clavis. Nice to see you again, outside and not raining. Woohoo!
We are lucky, effectively.
Yeah, it's great, isn't it? It actually feels like a festival, doesn't it?
So this year we are pleased to bring a few things which were already presented in some form last year, but also something brand new. So quickly, before going into the details, we had presented previously Tweakers, which is a pure analog module about preparing the modulation that you will insert into your module. So you put it in front typically when they lack these kind of features. We'll present our new logic module, which is different from the prototype we had last year. So it's finalized and currently in production, so very soon into the shops. And then brand new for this year, we have this Grainity, which is the first granular VCF available in the modular world.
Okay, I don't know what that is.
So we'll cover it in a moment. The Tweakers is a dual channel module where you bring a CV, you get it out. It is duplicated into the second input so that you can get it in two directions. If you go to two targets at once, you can prepare a level and you can have an offset. This is both negative and positive, and then you can invert the polarity of the main signal. The offset is not inverted, and in the middle it's muting the channel. So you can prepare levels and possibly even use the module with only one in, one out, and have two sets of settings properly set as needed for live performance. Otherwise it's also a mixer, of course, so you bring two different inputs and get the result mixed on the B output. So it's quite multi-purpose. The new 2-bit in its new presentation is a logic module that complements and does not replace our presently available Logica XT. And it's more for multi-purpose, main purpose, because you have also two sections totally independent if needed, or that can be changed. You can change the output to the next module, normally or inverted. And in that case, it creates like a third input, so it's 2 into 3 into a result. Each section has both its normal output and inverted available at once, simultaneously. And in the second section, all these features in red are CV controllable, which is new here. We do not use the CV to call the functions, but to modify their length or effect. For example, the random, you change the percentage of randomness that goes through. A comparator is a pure voltage comparator, where you can compare analog voltages against a fixed value. You have a multiplier or clock divider also, and we end up with the delay, whose length is available through CV control. Of course, all of these are also set manually with a new set function, where you modify, you set on. It says which way you should go, so currently the setting is low. Then you grab it, and then you put it somewhere, you see, and when you are okay, you just leave it and it's done. Very easy. So now, the main piece for this show is the brand new Grainity. This module is based on a 100% analog path that is creating a number of filter variations, more than what is available on the panel, because this is a second filter, in fact, available on separate output. So we have a main input, the granular VCF output, the multi-mode VCF, which is this small thing here, and both can be mixed in the mix output. The mix is controlled by a knob, but also by a CV. And then we have typical filter functions of frequency, resonance, both, of course, with voltage control. And then comes the special trick of what is granular VCF. It consists of slicing and reassembling bits of filtered elements from the incoming signal according to a pattern and according to a rate. By default, the rate is the one coming from the cycle of the audio, but you can bring a cycle from the outside because the detection input is available separately, while it is normally normalized from the main in. So when you just bring main in, it automatically goes into detection.
It's like an audio rate sample,
audio rate slicing, yes.
Okay.
And reassembling, yes. Beyond that, so you have a number of tables, which are definitions of which filter mode we use. In total, it will choose among 13 different options that can be assembled in different ways. From that, you can apply a divider which will say, do we slice at cycle rate or half cycle rate, and we go dividing by 1, 2, 3, 4, 8, 16, 24, at which point when we go in very high values, it sounds more like a pattern sequencer. And then we have a track function. This is something quite unique because it is measuring the cycle of the incoming signal, creating a virtual slicing control oscillator that may cut the rate in a totally arbitrary rate, but still related to the incoming one. So that's a lot of technology, blah, blah. Let's hear a bit about what it does. So first, let you hear what we are listening to. It is, what we hear is only this. So it's a simple saw coming from an oscillator here. So it's all we use. So I connect it here. And what we have is that we can change, of course, filtering. You notice that the filtering does not follow the usual expectation of what a normal filter does.
Interesting. It almost sounds like it sounds like wavetable almost, doesn't it?
Yes, despite being its own signal cut by itself. Then you can divide. And then you can divide even further. And if I increase the frequency, but I divide further,
so we're actually hearing, that sounds like
the slicing, yes.
Yeah, almost a waveform in the modulation.
Yes. Now, another thing I want to show you is this tracking thing. So, when I activate that, it is extracting the incoming frequency and creating another one, and I can detune it. Here, it is put on the 5th, as you can hear. So there is no modulation, it's only the shifting of the incoming frequency with the one generated derived from it. I can detune it in non-harmonic ways, or going to up.
Interesting. That's really unique.
It's only filtering.
Yeah.
Could you believe it?
It almost sounds like there's multiple oscillators going on there, doesn't it? Because they're beating against each other.
Of course, you can also change the type of filter that you mixed it with. So you get different.
Man, that's great.
Thank you.
So this is, where are we in production?
Currently, this is the second prototype, and I'm almost sure there will be 2 more. One to correct the big mistakes, and maybe a very last one to correct the very fine-tuning of the product. So we expect, nevertheless, to have it still during this year as a finalized product, from which we will start production. If we are lucky, that will be production starting before the end of the year, and I expect to have it roughly around the end of the year or just beginning of next year in the shops.
Okay, and what sort of price point are you aiming for? Do you know?
From what I know today, taking with some reserve, it should be under 300, all taxes included, in euros.
Okay, right.
Yes.
I see. And is there some sort of digital brain going on in there, or is it
Yes,
all in that?
yes. In fact, under the analog path, which is really from in to out totally analog, all the bits and wires manipulating the thing are all processor based. Yes, but there is at no point any audio entering a processor and being processed in any way, except detecting the cycle, just the frequency.
Right. Well, that's common. I mean, because you use a lot of digital in modules and logic. And it's
yes.
Clever
exactly.
uses. Yeah.
It is the use of logic which allows this kind of things. Yes, but even the switching is purely analog switches.
Eric, thank you very much.
Thank you, my pleasure.